this motherboard fault is no display issue, and firstly I'll give supply. Now this is the normal standby voltage of this board because 3 volt is generating after power button. That is why this value is so low. Now I'm coming back to this board here. If I should power this board, I'm getting good readings on the DC here. I'm getting good readings, and yet no display. In fact, fluctuation is coming a bit, still yet no display. So aside from that, the board is even misbehaving at times. It won't even the readings will come down totally. So let me try the second RAM slot and show you guys the other one. So mo ń sọ mo ní wọ́n gbé board eléyìí wá fún no display issue, and consumption ẹ̀ lẹ ti rí ní earlier on here. So mo fẹ́ lo another RAM slot. So this is the second RAM slot here. Let's test it and see what the reaction is. I've inserted my charger and I've given supply here. So this at this second slot the voltage is dropping, and now it will go off. You see, so that is the issue for this motherboard. Now let me reuse this part again once again, and let's retest if any display is coming. Screen flex is connected properly and the supply is giving already. Now let me give the trigger. So this is the fault, still the same thing. Okay, I'll use this RAM slot that is giving me at least good readings. This is an SoC board, and at that particular readings ó jẹ́ kí n ti rí display. So what I'll do now is I'll go first by checking all the coils, then I'll check RAM requirements, and what should I check next. So let's do that first. Now I've plugged back my adapter and I've given supply. All I'm going for now is I want to check all the all the coil supply and check RAM requirements. That is the main thing I'll check here. Firstly, let me start from this part. Since the board is powering, I don't really need to stress myself by going from low to high. So I'll just go through all the coils. Firstly, this is the first coil here, 1.5, which means this one is for RAM present. This is another coil here, 1.09. Other side, 1.07. Okay. Another coil here, 1.8. 1.7 approximately 1.8. This is another coil here, 0.8. Okay. This is another coil here, 3.2.8 fluctuating. Let me check the other side. 2.7. okay, this is another coil here, 1.1. Okay, this should be battery coil, so I don't think this one is really necessary. So going for the next one, this is 3.3. this should be for 5 volts. Then this is 5 and 3 volts. Fine. Okay, since all the coils are now supplying, and at the other side of this board there is no any other coil there. Okay, basically firstly nígbà tí display yẹn ò wá kí la ṣe àti kọ́kọ́ check gbogbo coil yìí, gba àwọn coil yìí dẹ̀ ti supply pátápátá. The next thing tá máa ṣe ń sìn ni wípé a máa wá sí kíni requirement RAM section yìí, and firstly the requirement a máa check first pin fún half of the voltage. This is the first pin here, 0.78, half of RAM supply. The last pin here as well, 0.77 present. Second to the last pin, which is okay, 3.3, and third to the last pin, 3.3. okay, these two 3.3s are for clock and data. Okay, let's check for PLT reset. 1.5 present. Okay, let's check clock and data communication of the RAM. To share clock and data, you have to turn off the board. Now the board is turned off. Then I'll come with my pin number 200. This is pin number 200 here. I'll turn on my board and trigger the. Okay, let me first locate the trigger button. This is the trigger button here. So, and I have my probe at my testing point here. Do you see any signal? Let's recheck. You have to pay close attention here. Let me trigger the board again. Nothing is coming. Nothing is coming there. Okay. Let's check the second one. Which is the third to the last pin. I'll trigger the board again. Nothing is coming. Nothing is coming on the clock and data pin. Okay. Actually, this is a clue for me since I don't have my clock and data. And here I'm having PLT resets. Let me confirm this PLT reset. 5, 10, 20, 30, pin number 30. Let me trigger my board. 1.5. I'm having PLT resets and yet no clock and data. Let me check the main supply for RAM. Pin number 82. 70, 72, 80, 82, 1.5 main supply, RAM main supply also present. Okay, but no clock and data. Since I don't have clock and data, first thing, let me check the PLT reset if there is any PLT reset at all. Okay. Pin number 22. PLT reset is present. PLT reset is present. Okay, still yet no clock and data. What I'll do is I'll reprogram the BIOS. I mean the main BIOS, not the EC BIOS. Summarily, nǹkan tá ti ṣe so far ni wípé lẹ́yìn tá ti check gbogbo coil yìí wọ́n ti supply. I check RAM requirement. Nínú RAM requirement yìí PLT reset ó wà. DRAM reset ó wà, but clock and data ti section yìí kò wà. Ọ̀nà náà wọ́n máa ń sọ gan pé DRAM reset yìí confirmation pé gbogbo section yìí ń ṣiṣẹ́ ni, but theoretically as you can see àìtí rí signal, àìtí rí clock and data communication, voltage lásán ló wà níbẹ̀, àìtí rí clock and data communication, DRAM reset òun dẹ̀ wà ní tiẹ̀. So without wasting time, our kọ́kọ́ program BIOS náà ká tiẹ̀ to check anything, whether be LPC frame or blah blah blah. So I'll connect my programmer. Here's my picker. Now we have two BIOS here. Since this one is closer to this one, this should be for EC BIOS, and this one closer to the PCH here, then this one is going to be for the main BIOS. So now what I'll do is I will program the BIOS. I mean the main BIOS, not the EC BIOS. Tá bá fẹ́ program BIOS tó bá ti jẹ́ display issue, main BIOS òun ni a máa program. Tó bá jẹ́ power issue, a máa program EC BIOS. So the BIOS is out. At times, if you need to confirm if you are right with the EC BIOS or the main BIOS. Now I have the main BIOS out. I will power the board and see if it will power at all. Bẹ́ẹ̀ confirm bóyá main BIOS àbí EC BIOS ni mo yọ. So mo ti tan board yẹn as usual, taking consumption. Màá tan owó bóyá ó máa tan. So board mi tan. Bó tiẹ̀ tan yìí ó means pé EC BIOS ló wà lórí board. For the fact that my board has powered means this particular BIOS is for EC BIOS. So what I will do next is I will go to my collection and see if I have, what's the part number, LE8943. Let me see if I have it in my collection here. These are my 5 tested BIOS. LE_89. Okay, I think I have this one, so I'll open it. Okay, I have 3 files here. If I have 3 files here, this is my main BIOS 4 MB. This is, it means I think this IO is programmable. That is why I have this very small size, 131 kilobytes. But this is not my focus now. Now this BIOS is out, 4 MB here. Okay, let me read this one and see what is the size of the BIOS. This is my programmer here. I'm opening my programmer now. Let me see the size. Okay, I have 4 MB here. 4 MB ni, oh no, this is it here, 4 MB. Okay, so I'll read. This is the 4 MB here. I'm reading. Okay, let me save this one with LE_8943P dump. I might need it, so I've saved it. Now let me program with the 4 MB I've copied here. 4 MB. Okay, here is it. I've opened. Let me write this. So auto erasing, I didn't bother to erase my chip because it will automatically erase whether I erase it or not. So now let me get set to return it back on the board. Now the program is really writing. After this one, it will verify the writing and then to conclude everything. So nísìnyí mo fẹ́ program ẹ̀ pẹ̀lú BIOS mi lórí board and ó ti ṣe tán sí pẹ̀lú programming. Next thing tí màá ṣe ni wípé màá dá padà sí orí board mi. Okay. Paste díẹ̀ wà níbẹ̀ tẹ́lẹ̀, so mi ò lè ní the paste. Okay, the BIOS is back in, so now let me clean this. Good. So now I will retest this and see if there is any changes. Now I've powered the board. I've given power. Now I've triggered. Let me see if there is any improvement at all. Since it's like I'm having around 40 something. Let me check the clock and that. Or before doing that, let me first test with screen. Then I will confirm. Now I've given power, so let me trigger. Let's see if there is any changes on screen before I do anything. Okay, not okay. Now I have my display and my laptop is working fine. So let me go back now and check the clock and data communication. You know, the clock and data wasn't coming initially, and that was why we actually programmed the board. I don't want to remove this fan. Normally I could have removed it and continue testing, but I don't like to remove the fan when I'm troubleshooting display at very high level. I mean the current consumption at high level. So mo ti tan board mi padà ń sìn, and mo fẹ́ confirm pay to reset. Mo need that confirm voltage reset. Mo fẹ́ confirm. This is the next board now. When I'm done with this, this is my, okay, let me use here. I need to rotate the board because of the trigger pin. So this is pin number 202. Now let me trigger the board and let's see if anything happens. Trigger button. Does anything happen? Nothing. But the only thing now is this line is now straight, unlike before. Now let me check the second one again. Nothing as well, but this line, okay, yeah, now I have my signal. Okay, good. Let me redo it again. No, before the 2 was not even coming at all and the line is not straight. I think this other slot is failing or something. Let me recheck once again. Yeah, I have it this time around. Now let me check the first one again. This is pin number 202. Yeah, I have my signal now and the line is straight. The one thing I'm very sure of that is that this line is now straight in this working condition, unlike how it was doing before. So now let me even use this RAM slot. Now you know this RAM slot, if we should put in the RAM there, the board will turn off. So now, okay, even this pin is not working properly. Let's see if it will tip off. This part is not tripping off anymore again. This part is not tripping off. I think my job is now done. So what I'll do now, let me retest with display on the second RAM slot as well. Let me give power. Do we have display? Yes, and my display is now coming perfect. So thank you for watching.